Alright, so if anybody has anything you want to talk about tonight, let me know. And... Oh, the new whiteboard. Yeah, that's what I was talking about with the web app. Let's see, do we have... Nope. Oh, there it is. Ah, cool. Oh, good. So that's all saved on the cloud. It is not saved locally. Good to know. Come Yeah, thanks. So, it's been an interesting week thus far. It's only Wednesday. uh, had two of my classes twice and won't see them again until next week. And one of my classes is only come up once, so we're going to meet tomorrow. Sorry, no, that's two of my classes we've only met once. We're going to meet up again tomorrow. Um, Seems like a good bunch of people. Think we're going to have a good time. I hesitate to say this out loud because you never know, he might be here. One of my students was like, "Hey, so we could do an independent study, right? Because like I can't make it during class time." I was like, "I don't think our school has ever done independent study, at least not for math." So I was like, "Well, let me just check with the dean, but I'm pretty sure it's a no." So or I sent an email to the dean who was like, "Do we even do independent study in terms of math? And if so, what does that look like?" And within 10 seconds, I got an answer. It was two lowercase letters. No. Not even bothering with capitalization or punctuation. It was that dismissive. I was like, okay, you have strong feelings. And he was like, okay, well, just out of curiosity, why not? And I was like, well, I'm guessing that it's probably cost benefit analysis. You have to still pay a teacher for like a student, and you get basically no like benefit to the college. So I was like, yeah, okay. All right. Oops. Cooler Yellow, how's it going? Seem chipper this evening? Yeah, and only a few minutes late. uh, Gotta love technology. Whoa. Yeah, no. Oh, I thought I'd let people figure out what we wanted to talk about, but generally speaking, up for anything. So we've got. I was talking last week. I've got my TensorCalc book here. I've got my PDE book here, which are both things that I would like to explore eventually. But you all can watch me bumble my way through it in an awful sort of way, or we can pop into all sorts of other stuff. So I've got advanced engineering mathematics here, which is mostly going to be the multivariate differential equations and linear algebra class, but we can find some application out of it. Of course, it is under my actual monitor, so that's a little awkward. Maybe I shouldn't offer that. Other than that, we've got, let's see, math analysis. Topology might be fun, but at the same time, I'm really worried that I'd just be sitting here staring at the screen doing nothing. Or we can talk about stuff that other people want. So there. So I don't know if you're interested in anything particular tonight, or just come to hang out. So I think I was probably saying before you got here, my classes have all met, and everybody seems pretty chill. I'm gonna have a good semester, I think. Oh, and I did my spiel about how math is, you know, less about doing the eternal verities and finding out the absolute truths that exist in the world, and instead looking at the general topic of relationships. The fact that, mathematics is axiomatic, so you can break it down into its constituent parts and then work on bits and pieces to try to figure out new things about figure out the new relationships that exist in whatever axiomatic space you pick. And I think all of them actually sort of got it. I was like, what? Just like, yeah, this is great. So I might have scared off a couple of people, but that's all right. I haven't gotten any notices of withdrawal, so nobody was scared too bad, I guess. But yeah, everybody's kind of like, I think everybody kind of was receptive to the idea that, we're looking at reframing mathematics instead of how they're used to thinking about it. Because like all the liberal arts majors who are there really need a different perspective. They can't keep doing what they're doing because they're all like, I'm not good at math. It's not my, it's never going to be my subject, all that stuff. So I'm trying to break them away from that particular attitude and mold. Might work. Certainly hasn't been tried yet. Nah, I mean, we have better teachers than I at my institution, especially in this particular class, but their methods of motivation are not necessarily compatible with my particular attitude. Me, I just get really excited at doing math. I mean, there's other stuff too, but you know. Gotta gotta be honest here. I didn't even read what that notification said. Um, something about go ahead and try putting your eraser over something. I'm like, yeah, okay, I know what an eraser is. Um, so, what's your particular topic of choice when you're doing your graduate work? Do you have any? I mean, you don't have to give away anything. Obviously, I don't want to get you scooped or something, but if you have a particular favored field or anything like that. Hmm. Okay. All right, that's fair. Any favorite programming languages? Mm. Oh, you were doing were you doing neural networks, or am I thinking somebody else? Here we go. Background blue and mesh. Yeah, the what's your programming language is one of those things that you just don't broach. It's like you said, like religion, politics, and what's your thesis on? Never ask a graduate student what their thesis is on. Oh, so rude. Back in college, and most of the time after college, at least for the first 5 or 10 years, I was reading a lot of web comics, and Piled Higher and Deeper, or PhD, is one of my favorites. That was one of the things. Like the new graduate student comes in, and he's at a party with all of the other people, and the perpetual PhD, the guy who's been there forever with the slightly long, shaggy hair and Birkenstocks on his feet, always goes into talks with the express intent of raiding the food table and then leaving. Is standing next to him, and he's like, "Look, you got to get in here. You got to talk with people because like you're gonna network. It's gonna be great." And he goes, "Oh, okay. hi, my name's John. Um, what's your thesis? And she goes, ah. And Mike's like, whoa, dude, that is just way too forward. You can't do that. It's like asking her weight. What are you thinking? Yeah, I did a little bit of JavaScript, so not not Java. Um, did a little bit of JavaScript on like Khan Academy and stuff, which had that auto compiler in it. It's really nice to be able to see in real time what you did automatically. Um, and then you're gonna love this one. Um, our When I was working at the insurance company, our database system was using Visual Basic. So I learned how to program macros in Visual Basic. And then, like before that, in school, I had been learning MATLAB and Scilab, the free French version, and then I learned a little bit. Well, I learned C as one of my classes. In one of my projects, I had found code to do something in C++, but I don't know C++, so I was like, well, I can edit it. So I pulled the C++ code for a uh, Cajonin auto, well, what's it called? Self-organizing map for my neural networks class. So it's a C++ program, and I'm like, well, I can't program C++, but yeah. So I just edited the whole thing to make it do what I wanted. And, I was open about this. My teacher's like, hey, you know what? That was a great job. Not doing more than you had to. Cool. So it was just like a raw self-organizing map to do random stuff, and or like to the goal of it was that you'd put points around the map, and then they would be of different colors, and then they would automatically spread out and then um, form boundaries at you know wherever they grew to. They'd hit each other, and then they would start negotiating boundaries. Um, yeah, it was so terrible. Like, you people need to get a better computer system, because, or a better programming language on this database, because it's just no. Like, it worked fine, especially since for everybody else on the floor, what they were doing was they would record their keystrokes and just do macros to like speed up the process of data entry. Um, Collision detection, sort of. So there's a part in data mining where, like, I mean, it's probably called collision detection or something like that, but anyway, um, there's a part in data mining where you have like a bunch of scattershot stuff. So you have a bunch of data that ends up being in like this area with some sort of like, normal distribution around this particular point. And you don't know any of this ahead of time. And there's another one that has a normal distribution around this point, which goes like this. And again, the stuff inside the area is randomly distributed. But the thing is that you don't know what actually belongs to which group. So you have to figure out with a certain probability which group each of these points belongs to. So, if you find a point here, what's the probability that it belongs to either of those groups? And that's probably going to be like a, 30-70 or something like that. I'm just making it up off the top of my head, but still. I'd be willing to bet that's probably about right. Yeah, but also the macros for this particular Visual Basic were um, terrible. um, no, the like the variable names that they gave it were just so awful. Um, which I mean, fine. It's it's Visual Basic, and I'm not doing it anymore. But still, it was just like long ass things. I was just like, all right, I guess. And then a few years ago, I can't remember exactly when it was. I was like, I gotta learn something. No, actually, right about when I was still finishing my uh, grad school stuff, my spouse had been doing computer science, and she had been doing everything in Perl, and I was like, all right, let's hear it. So she taught me a little Perl, and I started like doing the online Euler project. I think I started doing that in Perl, and I didn't get very far because I had other stuff to do. Yeah, I've restarted Euler project 3 times. One was with MATLAB, one was with Perl, and one was with Python when I finally got around to installing the thing and being like, all right, well, why not do Python? Because pretty much everybody seems to be wanting to go that direction. Anyway, so yeah, the what you had was a like rectangular space, and it's assigned like all these points are assigned randomly in the space. So let's say it looks like that. And then the outer boundary is like, let's just make it small. Something like that. And then the self-organizing map would basically take every single point along the entire, or in the entire space, and say like, all right, which one is it most close to? And then based on that, it'd give it a like percentage of it being black, green, blue, or red. So something up in this corner is like almost definitely going to be black, and then this will, spread out like this to where it is definitely going to be part of the black group. And then the green one is going to be similarly like immediately surrounding it is going to be almost definitely part of green, maybe a little bit up further this way. And then these would start, again, they'd start like negotiating boundaries, which is what I was saying. But anyway, blue would cover all of this stuff maybe. And then red would be all of this in here. And eventually this works its way out and around to where all of the other ones are. Here to there. And then like the ones that are in question, the ones that are close, it'd start like reasoning, all right, based on the other information that I have, what's the probability that it belongs to each of these individual groups? And then it would spread out, and they'd also start pushing a little bit on the boundaries, each one, checking, is it more toward this or more toward that, and then it would lock into one of the 4 groups. I also had one that was, it would do the same thing, but it would do it randomly. So you would have all of the pixels on the entire space were randomly selected RGB colors. So 0 to 255 RGB, all 3, completely random. And then what would happen is that each one would have like a strong pixel selected, and then all of the ones surrounding it would start coming slightly more toward that color. So they'd all take like a 5% step toward that color, and then as you go out further, it lessens like normal distribution. So like this black pixel over here would suddenly turn slightly more green because it's closer to a green pixel which was selected because it was the strongest pixel within its immediate surroundings. So like they would look at kind of like what colors are sort of similar to being, which pixel has the most pixels surrounding it that are similar colors. And so it would select that pixel, do a circle around it, and say, okay, based on that, these ones are going to all turn more toward the color that was selected. And then it would go to another random point, or another point somewhere outside of that circle, and say, what's the strongest, what are the strongest pixels? And it would do it kind of in order until it reached the bottom of the list, and then it'd start over again. Be like, oh, let's do it again. So then it would start like, colors would kind of go back and forth and wave up and down a bit until it found a balance. So that was an interesting neural network. But anyway, I stole that. Possibly. So I stole that blatantly. And, I mean, I credited the people. I gave them, put it in my, who's it's? I put it in my references and all that at the back, and the teacher liked it. So, couldn't have been bad, right? Famous last words. So I took it, and I made a predator-prey scavenger model out of it. So that, like, all of the... I think it basically did the same thing where it would... flash up a certain color, it would turn more toward whichever one color it was like close to, and then as it started going, it would use a partial differential equation. It used a partial differential equation to then determine the predator-prey scavenger model, and all of the values would start changing as an area got more flush with predators. Naturally, the prey started dying out more and eventually would just die off. And then the scavengers would come, and so the area would turn more toward the scavenger color than the predator color. And if there's no prey, the predators are going to start dying out, and so the scavengers get much stronger in that area. And then it would be like over in this region, you'd see more prey start coming out, and then predators would follow them in, and the scavengers would follow both. And then as it went through this cycle where like the whole map would kind of twist around, and you'd have the red go into the green, the prey, would go into an area, and then it would start turning brown because more red predators are coming in. And then once it turned more brown, it would start turning more red because then the prey are all dying out and the predators are there. And then it would turn purple because the blue scavengers would start coming in. So it was this nice little cycle of colors that just went all the way around the whole map. And, depending on the initial conditions, it was completely random. So, like, it would look different, but eventually it would fall into roughly the same patterns. And naturally, being a partial differential equation, it doesn't have an analytic solution. So this is just, it's going to end up becoming chaotic. So it starts going into this chaotic motion. So you don't know where everything's going to show up, but it's roughly going to follow the same pattern. I don't want that now. Yeah. Yep, so I did the same thing, or roughly speaking, where it was, in my mind, it was wolves, deer, and vultures. So it was 3 species working into the same area. So I really liked it. There were some times when it actually ended up crashing the system, not computer system, crashing the ecological system. So the predators would end up completely killing all of the prey, and then the scavengers would come in, and then the um, predators didn't have any prey on the entire map, and so they'd end up dying out, and then the scavengers would come in, eat all the predators, or eat all the predators' bodies, and then it would eventually go black because there wasn't anything left. Like the scavengers didn't even have anything to work with. Yeah, and it is an ecosystem. It's um, it was modeling for um, three variable differential equation. So it was ended up being a partial differential equation that needed three a 3 by 3 system of differential equations in order to solve. And yeah, like I said, it's not analytical. It's like the three body problem. You can't discern exactly what's going to happen. It's just going to start doing chaotic stuff. It was a real fun problem to work on. And like I said, I just kicked around C++ a little bit until I got what I wanted in the system. And, uh, I had the, dr, dg, and db for the change in each of the colors based on the differential equations that were representative of their particular species. And then everything needed to be normalized because I needed to make sure that it was not going outside of the 0 to 255 range. Which also could have been part of the problem, because if it started being like, oh, well, now we have values that are like 3,000 here, but you can't be at 3,000. This 3,000 needs to be clipped down to 255, being the highest number anywhere in the map. And then when that happens, that means that anything that was like 10 is now going to be tiny. Like less than 1. So I'm sure there are flaws, but it sort of worked. So I did partial differential equations, and then I also did nonlinear differential equations. I really like that. Yeah, game economy. Oh man. I just recently picked up EVE Online again because one of the other streamer friends out there was like, I'm going to pick up EVE because we got this Doctor Who thing going on. And I was like, okay, time to get my addiction back in. Unfortunately, I missed like most of the event, so oh well. I couldn't get into it for some reason. It was like I ended up doing, I mean, work kept getting in the way. But it was like I would need to go to a system, do some fighting, and then uh, like you get a thing, and then you go into the space area that it takes you, and then you fight, or you're not even fighting. It's you're scanning down little boxes. So you go over and you scan down the boxes, and then open them up and get resources. And you're supposed to eventually make a like bigger version of this out of the pieces that you're finding in the boxes. But like I never got really big stashes. It was always really small stashes, and so I needed to do like 10 more in order to get to the one that would give me the next achievement. And whereas it was a little fun, it got kind of tedious to scan down these areas with boxes. And then like other people are there too. I'm like, if you create the little keys to get into your own space, nobody else can get in there, so you are the only one who can loot it, or you and your friends if you bring friends. But I was just like, yeah, I don't know, it's not working for me. Those were also fun because you had 20 minutes, and if you did not finish within 20 minutes, your ship would explode, and and you'd be dead like instantaneously. And I'm like, oh, that's great. I don't need that kind of stress in my life. But yeah, Eve Online was my addiction back in college. I started back in '04. Um, so yeah. My Eve account is now old enough to drink in most European countries. Um, that's insane. Can't believe it's almost been 20 years. Uh, but yeah, I also crashed one of the markets. That was kind of fun. It was only one item, and it was only in one place, but still, it was like that is my claim to fame. I completely destroyed the market in this particular item because I found some place where they were like the only people who were selling it for stupid, really tiny, or they were selling it for ridiculously low prices. And so I bought like the entire stock of the entire region. Everywhere that was not super dangerous, I just bought out the entire stock. And then I put a buy order in for like the only buy orders that were there were for like 5,000. And I'm like, no, this thing is worth at least 300,000. So I put in buy orders for like 250, 300,000. And I was perfectly fine to pay that because I had a lot of cash at that point in Eve. And then I took my stuff, went across the border to the next region over where the market is independent and they're purchasing them for like 1 million. I was like, really? So, if people just look around, they don't have to just sit in one place for a long time. Just right over there, guys. It was like 5 jumps away, which is not a whole lot of time. There's a slight danger in that uh, people were doing sniping at the gates. So what would happen is you would jump into a gate to jump to the next system, and then because you still have to traverse about 15 kilometers, they would take pot shots at you. And if they're any good, their entire ship is just basically a throwaway battleship. They were able to tank the Conquered police force for about 10 seconds, 30 seconds, but that's all they need to shoot down a hauler. So they would blow up the hauler, and then their friends would be somewhere nearby, and they would just kind of putter over to the cargo containers that got dropped, and then grab them onto their ships. That's it. So I was like, I never ran into one of these people, especially in this area. I'm sure they were there, but they never targeted me. The other thing is that I would put everything in a locked container inside my ship, so even if they scan me, all they would see is a bunch of locked containers. So that's like worth nothing to them. But yeah, I'd go around and I'd pick up all the things that I bought for like 300,000, and then I'd ship it out 5 jumps to and sell it for 1 million. And then I started going, I can do better. Sorry. Anyway, um, so I was like, I can do better. So I started upping the price in the sell location from 1 million to like 1.2 to 1.3 to 1.4, and like they kept buying it. So I'm just like, all right. And then in the purchase system, I was the top competitor for purchasing. So the price entirely matched what I was putting down. And so I was like, all right, 250,000, 200,000, 100,000. And people kept selling it to me, and I'm like, oh. So my profit margin just keeps swelling, and nobody's noticing. And I'm just like, this is insane. How do you not notice this? So at the height of my purchasing, I was purchasing about 1,000 of these things a week at somewhere between 50 and 100,000 credits each, and then selling them at 1.5 million, maybe a little bit more at the other place. And still, people were buying them. And I'm just like, this is stupid. And then I was like, okay, I have one, officially crashed the market for this item, and two, I'm out. Because imagine this, imagine this, I felt guilty. Like, the hell, man? How did I feel guilty about that? Of course, when I was doing this, it was right around 2008, which was the real life market crash. So, like, I think maybe I saw that, and I was like, I don't want to be one of those people. Which is too bad, because it would have made me so much more money in-game. So, like, it was pretty soon after that I just kind of quit and stayed out for several years, till about 2012 or so. I was, I'd come back, I'd check my skill tree and make sure that I'm still earning my skill points. But eventually, I was just like, all right. Sometime around 2016, 2018, I just kind of gave up on it entirely. Stopped paying my bills. And then I found Elite Dangerous. Yep. They're not technically allowed to, but, like, who's going to stop them? Right? The only thing that happens is they get banned. Okay. If you sold that item in-game to your Sock Puppet account, then, you just keep doing the missions with your standard account, give the items over to your Sock Puppet, and then sell them for real money using the Sock Puppet. And then they can't catch you. They can't catch you. They can, well, I mean, I guess they could technically, but if you're supplying somebody who's selling ISK for real money or selling items for real money, in theory, they could crack down on it. But yeah, if you've got what looks like a legitimate sale between players, then I don't think they can actually do anything. Except ban the primary account, or ban the Sock Puppet. Yeah, I know. Oh, there is. I don't know if they have automated it, but I mean, you can just go into your own wallet, like your personal wallet on your account, and you can see exactly what you've done. So if you have transferred items or if you have transferred credits, you could definitely see where that is. And the devs definitely have that information as well. They wouldn't even have to dig that hard. If they know for a fact that somebody has sold something for money, they can watch that item transfer and they can say, like, it wasn't an appropriate, if it wasn't sold for an appropriate in-game amount, they could potentially flag that. And then if they notice that that also corresponds with a real-life account that has a similar, like, timestamp or anything like that, that's, again, not difficult. If it's, like, on eBay or something like that, they can know when it is. They won't get exact values, but it's close enough. I mean, eBay or whatever would get a bit harder, but they could also just, they don't have to know, they can just suspect. Just be like, I mean, this is one of the reasons why they started accepting, like, in-game money for Plex in order to do subscriptions. Because, I mean, people were just purchasing, like, purchasing ISK for real money and also purchasing their subscriptions for real money. So, whatever, it just turns out that it's going to be the same amount. And then CCP can get more of the money if they get in on it and say, instead of, you know, they're not going to sell ISK, but they're going to at least allow you to purchase game time with in-game money. Yeah. Yeah. I can't remember. There was something I was playing a long time ago that was like a World of Warcraft pseudo clone. It wasn't really a clone, but it was like a free version that you could. It was basically just battle mode. So you would get an instance, get with your friends, and then go into that instance, go kick a bunch of monster rears, and then come back into town and sell stuff. I can't remember what that was called. It was weird. Very cartoony compared to WoW. But anyway, yeah. So then I found Elite Dangerous, which was free and also allowed me direct flight stick control. And so that was really my push to get that one instead of play Eve. Was I'm much more of a flight sim kind of guy. Like my roommate and I in college used to play Jane's USAF flight simulator, and like we would do combat missions, and it was just crazy. Like the two of us working together to do, you know, being wingman and do all sorts of cool stuff. Yes, FF14 has stopped allowing players in. It's insane. Because again, they want to make sure that they've got their people who have actually paid for it to keep paying for it, instead of being like, well, never mind. Crazy. I'm going to see if I can pull up one of my old neural networks. I mean, of course I can. It's right here. Just man, I forgot how forgot how little information we got when we were doing these neural networks. Um, yeah, if you want to see a good one, the textbook that we used was Raul Rojas, and it was neural networks, uh, Springer Verlag, Berlin, 1996. He keeps it online and it's for free. Uh, and actually, you could probably get Rojas's book. You could probably get his book in German if you wanted. Or wait, no, you're not. You're not from Germany, right? I know Superbrain is. Yeah. Once I find it, because like I've got his homepage, but I don't actually necessarily have his book, which is too bad. The FAQ on his site is pretty awesome. Do you have summer internships? No. Do you offer scholarships? No. Oh, man. Okay, here we go. Okay, let's try this. So this appears to be at least the link to his page about the book. Let's see, if you click the... Nope. Okay. Hmm. That's slightly frustrating. Um, yeah, he used to have this book online for free. I don't see it right now. So it could be that he's taken it down. Either because there's, you know, newer versions available or something else. I don't know. I do personally have the entire book downloaded, but, you know, that's not shareable. Yeah. Yeah. Anyway. So my spouse and I were both in this particular class, which used his free textbook, well, that textbook. And so we studied, like, I mean, I wanted to go through the whole thing, but a lot of it's just seriously dense mathematics that we were not going to get to. But there were also really good homework assignments that we had. It was like, oh, you know, create this thing that does this, whatever it might be. um, is it just the same thing? Yeah, it is. Okay. Yeah, we ended up we ended up having a lot of fun with it because the class itself was really cool. The teacher was really awesome, and like he he gave us a lot of hints on how to do stuff, not just, you know, not just creating the programs that we were eventually going to work on, but also then working on, like, he told us if you do the, oh, there it is. Yeah, okay. I don't think I can actually get this to pop up somewhere, but let's see. Let's see. Window capture. Don't make the source visible. Okay. Yeah, there we go. Here we go. So this is my 3-species self-organizing map. I'm going to retrain it. So press B. No? Is that not a B? Yeah, there we go. Oh, apparently it's... Huh. P. That's not a P. Weird. Yeah, so anyway, on the first iteration you can see that it's all completely random. And in this case, this is using the predator-prey and scavenger model to work out what would happen with all three of them. Now, occasionally I do believe that this is throwing in like a random member of a different species or something like that for 1 pixel just in case, or it's so pure that it ends up attracting, like the prey is so pure it ends up attracting predators faster. That's L. Like, why is L the button to reach? That doesn't make any sense. Let's see. That's got to be in here somewhere. And now you can see it's slowing down. So after 2500, or when it gets close to 2500 iterations, it starts slowing down. It's not able to, like, I think it's set to do something like that, but let's see. Do I have it in here? No, not so much. Now this is the other project. So I have a different project that was all about taking... Let's let that go one more time, why not? Really? Again? We're gonna play this game? That was you. Or G, I guess, technically, on my... Why? Yeah, so the way that it works, and I don't have the code right in front of me, unfortunately. But the way that it works is you've got prey, and the prey will just die on their own, especially if any of these locations are overpopulated. Certain amounts of their species will die off. So if something is really like pure green, very, very bright pure green, there's too many prey in that area. And without predators to cull the overpopulation, they will start dying on their own. So you'll notice here, like the bright green spaces start turning duller and duller and more toward black. Did it slow down, or was that just my imagination? Because that's also possible. Yeah, it's definitely slowing down. Okay, so that's why I stopped it at 2500. It was just that it, and that was R. Why? Okay, R makes sense. That was just R. Why the hell was it doing the other thing before? All right, anyway. Yeah. So anything that just starts dying off ends up attracting scavengers, and that's both on the predator and prey side. If there isn't enough prey for the predators to eat, they'll also start dying off, and then scavengers come in and eat the bodies of anything that's dead. So, and there was some tweaking in terms of the values that you could use here. So there were some that, like, I used the I use the constants to kind of uh, figure out like what an optimal strategy would be, or at least what the optimal, like, this is going to look nice for a presentation is going to be. So some of them went immediately to just one species only. It didn't take 2,000 iterations to get there. It took like, 200 or something when it was just all suddenly all one species. And I'm like, all right, well, that's not going to work. So I worked out the constants, which allowed this thing to last for a much longer period. But anyway. Yeah, my final presentation for this was to create a neural network that was based on a program that Richard Dawkins had written for the Blind Watchmaker, which was his book on evolution and evolutionary biology. So he had created a program that would take a phrase, scramble it, and then evolve it back to whatever phrase it started with. Anyway, I do like that one. I was pretty proud of it. I can get rid of that one. All right, homework number 4 was to create a single layer perceptron, which was able to take the, oops, I'm not, oh, okay, I changed both. All right, whatever. Create a single layer perceptron, which would change, what was it changing? Yeah, I mean, it was just a test, but it was trying to create a thing that would do the thing with the other thing. It started with these weights here. So this was a connection between, you know what, let's go back here. Oh, okay. Let's go back here to the whiteboard. Yeah, that's going to just be the same thing as the other one. All right, whatever. Can't do a window capture if I've already got something else. That's also a window capture. Oh, that's why. Okay. Create new. Yeah, that's fine. Just call it window capture number 2. Yeah, that'll work. So go like that. Okay, my name's not on this. Cool. It's fine. All right, so basically what we've got going on is that let's do this. We had inputs of 101, which were going to come from input nodes over here. And then this had weights that were going to a second layer, and the output total was going to be, was it just 1? All right, how many Y's do we get? Yeah, if it's a single layer, right? This is what we've got. It's a single layer. We've got input x1, x2, and x3. W1, W2, and W3 are going to be the weights that are assigned to each of these things. And then we have our Y output, which usually we don't even bother with a 1 on this because there's only one. But whatever, it works. So then what happens is we kind of, or I randomize these at the beginning, or they were given to us. I don't remember exactly. It's been almost 20 years. 15. So our X vector is going to be equal to 1, 0, 1. And our W vector is going to be equal to negative 0.3, 0.6, and 0.2. Okay. So it's going to run the basic calculation for what we're going to get for Y. All right, we initialize. So up here, we're going to initialize Y sub j. I'm not on the... Let's make that go like that. Yeah, cool. So up here, we're initializing Y sub j. Now, normally, this could be a vector with a number of outputs. But in this particular case, it was just, give me one output. The other issue... The other issue with having multiple outputs is that you're going to end up with more complicated W vectors. So it's going to actually not be a single vector. It's going to be a matrix, larger matrix of vectors. So it ends up, we see that like down here, instead of being W11, W12, W13, I wouldn't have normally labeled it like that. That was a silly idea. So normally the way that I label this is that it's going to be going from each of these inputs to a specific output. This is why I have a 1 here, really, is that this one would technically be W11, this would be W21, and this would be W31. So I just screwed up my naming convention apparently up there. Because it's going from from input 1 to output 1, from input 2 to output 1, from input 3 to output 1. There being only one, again, you don't necessarily need that second one, but it's helpful to have for later, because when you make more complex systems, it works nicely to organize this stuff. So we can run a simple calculation as far as what we're going to get for Y. And what we do is we say, okay, we're going to get X times this particular weight is going to get us the Y component for that particular portion. So Y sub 1 output is going to be equal to, later on it's more than 1. So I sub 1 is going to be the sum as I goes from 1 to n, however many there are. In this case, it's just 3 of W I1 times X sub I. And I guess technically I want that the other way around because I'm just picky like that, but you know, X sub I multiplied by the weight attached to it, WI1. Now normally, again, when you do multiple outputs, this would be like Y sub j, which is why I have YJ in the notepad. And then this would be summed like that, and then we'd have a vector, which is then all of our Y sub j's with W sub ij. So we got both subscripts that would be in there. So the calculation here ends up being y1 is equal to x1 is 1 times a negative 0.3 weight plus a 0 times a 0.6 weight plus a 1 times a 0.2 weight. Based on that, we're going to get a negative 0.3, a 0, and a 0.2. So our output here is going to be a negative 0.1, whatever that means for the context. Okay, and then we recalculate our weights based on this delta J that we find, which is basically like how far off were we from our actual value. This is when you're training the network. So if we get this negative 0.1, I selected that y sub j, the actual value that we should get, is going to be 1 over 1 plus e to the negative x times w. No, that's, wait, hang on. Maybe not. Oh man. It's been an awfully long time since I looked at this. X prime. That's interesting. What was X prime doing there? Oh, right. That's transpose. So that's okay. Yep. We're good. I'm forgetting all my notation. It's fine. We'll just make it up for now. Okay, well, this is a sigmoid function or a logistic function. Looks something like this. We're inputting specific values and saying like, okay, we want our y output to be a particular location on this sigmoid curve. If it's down here, it's going to be rendered as off. And if it's up here, it's going to be rendered as on. And if it's in the middle, then we're going to be angry about it. Typically with the sigmoid curve, you try to get it as steep as possible. So like if you can get something that goes like this, all the better, because that means that this area where it's kind of ambiguous is hugely minimized, because the x values to get from here to here are going to be really tiny compared to this one, which is like here to here. So all that ambiguity gets taken care of. So y sub j is only a value here. That's going to be interesting. Oh no. Clearly I'm doing something wrong, but we'll worry about that later. Oh. Do we find... We don't redefine dj anywhere. So that's going to be important also. So DJ is a constant. See, I should have commented my code better. Nothing a little 15 years can't handle, right? So anyway, this is our like initial guess essentially. That our y value should end up being negative 0.1. Oh. All right. Anyway, let's get the TI out here. And all right, so like the first one is going to be 1 over parentheses 1 plus e to the negative. All right, and now we multiply those two things together. I already did that, so we can just take them individually. It's going to be a negative 0.3. So that's going to clear that negative. It's going to make it positive. And then here, that's going to get us a value for the first one of 0.42555574832. I don't need to keep all that, but you know. This one is going to end up being a 0 in the exponent, which makes this a 1, which makes this a 2, so that's going to be a 1/2. I should really be consistent. 0.5. And then the other one, right, 0.2. Ends up getting us a 0.54983399973. Also fair. Okay, so this is our y sub j. We're gonna make this a just a matrix for now, and then d really delta j. It's gonna be equal to okay, that is right. I already got that. Cool. Delta j is going to be equal to, these are all of the yj values multiplied by parentheses 1 minus y sub j times delta j minus y sub j. So this will update our delta j values, which will tell us how much our weights for each of the weights up there need to change. Oh, this is not delta j. This is dj. That's actually the one that was given. See, need to comment better. All right, so then this is going to be equal to, well, okay, the first one. A, start C. All right, so then this is going to be A times 1 minus A times 0.8 minus A. Okay, so the first one is going to be a 0.0915355855. Okay, Next one is what happens if we plug in 0.5 for all those. We get a 0.075. And then the last one, what happens if we plug in that last number? 0.0619202316. Okay. And then the feedback portion of this, or the correction part of it, is that we're going to take W11 and say that that is now going to be the old W11, old, okay, plus a factor, scale factor eta, which I let be 0.1, multiplied by our delta J, which we just found, multiplied by the original X value. Oops, 1. Delta J1, let's do that. All right, so eta being 0.1 is going to get us the scale factor. This is just a linear change, so it's going to change based on that thing that we found there. Store that into that random letter. Store that into this. And store that into that. Okay. So then this is going to be the original weight, which is negative 0.3 plus 0.1 for eta times the DJ1 that we just found, the 0.0915, multiplied by the original X value was 1. So didn't necessarily have to type that in, but whatever, it's fine. All right, equals negative 0.29084644415. So our new weight, instead of being negative 0.3, is now going to be this negative 0.2908. Hadn't changed all that much, but at the same time, like this is going to get us a little bit better of an approximation of what we needed to find. And then we repeat with the same here. So 2,1 is going to be 2,1 old plus eta delta J2 times x2. x2 is 0, so it's just going to wipe this out, which means that we're going to get exactly the same value for W21. Yep. So our weight doesn't change on the middle one, which ends up being a 0.6. And then W31 is going to be W31 old plus eta delta J3 times x3. x3 is just 1. So again, we get the 0.2, what we started with there, plus 0.1 times, that is F. All right, so this one ends up being, this is just going to be 0.6 still, and then this one is a 0.20619202232. Now, let's see. Okay, so in the original, the weights don't do anything in particular. Like, they're not part of a specific pattern. I know sometimes, like, they're normalized, so you end up with either a sum or an absolute sum that is 1. we're not messing around with them at all in this case. So the weight for the first one gets weakened a little bit from the negative direction, and the third one gets strengthened a little bit in the positive direction, and the second one stays exactly where it was to begin with. So then once you do the feedback correction, you could potentially go back in and say, okay, now instead of doing these, this is going to be like y1 new. It's going to be equal to 1 times negative 0.29008 464415, etc. plus a 0 for the second one, plus 1 times, and then that's going to be the third one again, 0.20619. Right, so then this is going to be that one plus that one directly. It's just going to be those two numbers. So now instead of a negative 0.1, our y1 new would be equal to the sum of those two numbers, because again, x is just going to be 1 and 0 and 1. Y1 new is going to be a negative 0.0846544 183. Now, realistically, right, I would never do this by hand. This would all be just taken care of using the code. So when you do it, you end up with right. I went with basically 2,700 iterations to get a mean square error of 0, with the final weights being 1.185 and 0.6 and 0.2. So turns out, right, the first weight ends up eventually becoming positive, and then the third weight ends up dropping back down to 0.2, which was the initial value we had for it. So, at any rate, this is like a random neural network problem that we ended up doing. Right, when you do much more complicated neural networks, so you end up with like 4 inputs, and let's even just do this. A middle layer, also called the hidden layer. So this would be x sub I out here. This would be y sub I out here, and I don't know, h sub I just fine here, or h1 sub I, you know, because you can have many hidden layers which do things. You don't know what they do, but they're basically the neural pathways within this particular system, which are going to be strengthening certain connections behind the scenes. So they're not doing any direct connections between the inputs and the outputs. These are like if there are any sort of hidden properties that exist. I know one example is like when you're doing image recognition. If you want to be able to figure out if a letter is a T, for instance, over here, we just have pixels. So it would be way more than 4, but nonetheless. The hidden layer in between might be like the first one is trying to look for, is there a right angle somewhere in it that looks like this? This one might be, is there a right angle in it that looks something like this? And this one might be, is there, I don't even know, is there a like sufficiently long vertical side? Or like with white space surrounding it. You know, is there a vertical line with some white space under in the bottom half, let's say? So these might be what the thing is actually looking for, but you'll never know. Like almost guaranteed, you will never be able to figure out what exactly this thing is doing. You can look at the code, you can try to figure it out, but honestly, it's not going to happen. And then over here, this is saying, is this going to be like a T? So, you know, I don't even know. Nah, I can't make that up. Basically, in the case of a T, it would literally be just one output node, yes or no. Is this a T? So the output here would either be a 0 or a 1, and there can be no in between. It'll just basically round it to whatever it's closest to. The other option is that it might, for instance, be, again, you've got all your pixels here. Here, you've got all your different types of structures that exist in your hidden layer. There might be multiple hidden layers which do like different types of structures. And then here at the end, you might have, for instance, 26 outputs for which ones are turned on, i.e., what letter of the alphabet is this thing most likely to be. If multiple of them are turned on, it's stuck in saying, like, I don't know which one it is, but it's one of these 2 or 3 or 5. So all of these have connections to all of the stuff. Which gets really messy. It is a complete map in terms of graph theory. So these would be, for instance, W. These be J. And over here, any outputs would end up being Y sub K, but we're only using the 1, so whatever, it's fine. So these are the connections Wi to J. And over here, these be Wi to K, which again, in this case, K is just, no, not I. Boy. J to K. So you can tell you're going to have a really like big matrix with W sub ij. Just because there are a lot of inputs, there are a lot of outputs, you need something that's a, in this case, 4x3 matrix. Hello to anybody else out there. If you have any questions, please interrupt me. So yeah, this ends up being a lot more involved because then you're doing all these calculations out multiple times. You have to feed this forward, plug in all of your inputs, then get the hidden layer values, and then get the output value at the end. And again, if there are multiple outputs, then you're ending up with you know, potentially multiple things that you need. In the case of my self-organizing map, this was how the uh, SOM network worked out, we had, all of this would feed into three outputs: our R's, our G's, and our B's. So you'd then have a color being the output for that particular pixel. So that's how the self-organizing map worked in that predator-prey scavenger model that I pulled up earlier. All right. So in a realistic model of what I was just talking about, where you're trying to do image recognition of a particular, shape or letter or whatever, what you're going to be looking at is you need to have inputs equal to the number of pixels that there are on the entire screen, or within your particular, within the particular area you're doing. And then when you're taking, your whatever image you think this is, right? Let's say it looks like this. You want to know what letter it is. It's going to be pretty easy, that one. But something like that might be a bit harder for the computer to figure out, especially if it's got, any sort of other artifact. If it wasn't trained on cursive, if it was trained on just regular block print, then something like this might trip it up because, who writes like that? If it was trained on like all capital letters and somebody writes an E like this, or if they write a capital E like that, right? Like these are things that are going to really mess up this neural network, but the image recognition can get at least close. So this is going to be a number of input nodes equal to the number of pixels that you're testing. And then here with the hidden layers, we don't have like a really set rule for this, but you might want to think of this, if you can program them more specifically, you might want to think of this as like the number of mini structures that you can create. Or just match number of inputs. And or outputs. Now, I don't know if it's best practice to put whichever is more, or if it's just you cross these out and say match the number of inputs and be done with it. All right, and then on the lower end here, again, we're doing letters, so this is going to be number of possible characters. All right, so then if it says, if the neural network comes through and does this whole thing and figures out that this is a G, as it oftentimes will, what it's going to do is it will go through this list of possible characters and be like, okay, we're going to punish all of the ones that it's not supposed to be. So it'll go through and knock down all the weights on the other stuff, which cause them to throw incorrect values. So if it's like, you know, it came up as a G, no, we don't want that to be a G. Let's punish that particular set. Then it's going to increase the weights on anything that turned out, like anything that was going to get it G in the first place. Like everything that linked to G gets strengthened, so it goes up instead. Not literally everything, but there's a, again, you use the math that's up there, more or less, and it changes the weights automatically. You get the computer to update it. Right, and in the realistic model, again, you have all these, which are going to go out all the way down to this last one here. So these other ones, like there could be a very large number of these things. It doesn't have to be, you know, literally only like 5 or 6. So if we have a large screen, like a 1000 by 1000 space that we're looking at, that's a million number of pixels. So usually you want to keep this down to a minimum. You don't want a literally 1 million input region. Although generally speaking, a million still is not that much processing power, because it's a small number of calculations that are a kind of limited amount of work for the system to do. It doesn't take much. So it's also possible to I think I just completely lost my train of thought here, but whatever. Yeah, it's completely possible to create a network that looks something like this. Again, this stuff is also going to go out to all of these in the middle as well. So you have an infinite, not infinite, you have a very large number of connections. So usually you want to keep your space small. Like I said, you don't want to do a 1000 by 1000 resolution area. You're probably looking at something that's like 5 to 10 pixels across and 5 to 10 pixels tall, generally. Right, especially if you're looking at just like a letter that's written somewhere. Okay. So, if nobody else is going to throw out something, I'm going to start looking at where we can go tonight. Alright, JCM's off for the night. That's too bad. A little music in our lives would be wonderful. Let's figure out. Who we've got. Sage is on doing Dark Pictures Anthology. Oh man. SDK's on for Phasmophobia. Star Citizen. I don't know what Dev's doing tonight. It says Stream Raiders, but that's always the case. Or else. Have some people doing LaTeX. Alright, let's go check out SDK tonight. So he's doing Phasmo. So thank you everybody for coming. This is Obi-Wan Pez for NSimplex Pachinko. I am going to grab some more water and hope to see you all on Friday for more games. We'll see exactly what I'm feeling like playing. Probably, yeah. I don't know what I feel like. It might be. I found a new game, or it was suggested that I play a new game. Um, it's currently free and it's a beta sort of thing, so we'll see how it goes. Allegedly, it's a little bit like Valheim, but I haven't played that far into it at all. So we'll start from the beginning and see how long it takes for me to crash it. Um, it's a little bit like Valheim, but it's like kind of South American um, indigenous peoples mythology, and so it's gonna. I think it's gonna be really cool and interesting. We'll see how it goes.